Today we're going to break down more polynomials. So I've decided to start with f of x equals x to the third plus 3x squared minus 25x minus 75. And the thing we know is that there will be, because the highest power is 3 zeros, and that when I break it down into all of its factors, there will be 3 factors, one that goes with each zero. The first question I'm going to ask myself is, can I factor this? And my answer is yes. I can factor this by grouping. So x squared, x plus 3 out of the first two terms, minus 25, x plus 3 out of the next two terms. So then I have x plus 3 times x squared minus 25, which would be x plus 3 times x plus 5 times x minus 5, which would mean my factors are x plus 3, x plus 5, x minus 5. And the zeros that go with that, negative 3, negative 5, and 5. Hopefully you would have seen that you could factor it as well, but suppose you didn't, and you decided you were going to just graph it. Okay, based on the graph, I see an x-intercept at negative 5, negative 3, and positive 5. So I would have, if I hadn't seen that, I would have not done this work. I would have said, based on what I see, my zeros appear to be at negative 5, negative 3, and 5. And I would have done synthetic division. 1, 3, negative 25, and negative 75. Maybe starting with a negative 5. 1, negative 5, negative 2, 10, negative 15, 75, 0. That one confirms. So then I would have written a factor for it of x plus 5. And I would have layered in another synthetic division using negative 3, 1, negative 3, negative 5, 15, 0. So I confirmed that one. Then I would have layered in another synthetic division, 5, 1, 5. I have confirmed all 3. So my factors, x plus 5, x plus 3, x minus 5. And my zeros, negative 5, negative 3, and 5. This is the same answer. And just because I did my synthetic divisions in this order, you could have done them in a different order. But we'll notice we get the same 3 factors and the same 3 zeros. Okay? The answer to the question, how many zeros will I get, is 4. Which means that I will have 4 factors. And although I'd love to think I could factor that, I don't think so. So I'm going to turn this one off. And hopefully I typed these in correctly. So that when I turn this one on, I'll get the graph. Okay, so what I'm seeing here is what looks like a parabola near negative 3. So based on the fact that the polynomial looks like a parabola at negative 3, I'm going to assume that 2 of the zeros are at negative 3. And I'm going to do synthetic division to confirm that. 1, 6, 13, 24, 36, 1, negative 3, 3, negative 9, 4, negative 12, 12, negative 36, 0. Correct. Plus 3. Try another one. 1, negative 3, 0, 0, 4, negative 12, 0. True enough. 2 of the zeros are at negative 3, so 2 of the factors are x plus 3 and x plus 3. Gone from a 4th degree to a 3rd degree, from a 3rd degree to a 2nd degree. So this is x squared, no x's, plus 4. I have to figure out what zeros go with that. So I'm going to set it equal to 0. X squared equals negative 4. Square root both sides. X equals plus or minus 2i. That's why my graph did not show them as x-intercepts, because they actually are just zeros, not x-intercepts. So one of them is at 2i, and the other is at negative 2i. So this would be a factor of x minus 2i and x plus 2i. And if you multiplied all those factors together, you would definitely get that polynomial. Let's go again. Again, I'm expecting 4 zeros and 4 corresponding factors. I don't think I can factor that. So let's turn this one off and turn this one on and graph it. Okay, it looks like I have 1, 2, 3, 4, negative 4, maybe 2 of them at 1, and 1 of them at positive 4. Okay, so those are my guesses. Negative 4, possibly 2 of them at 1, negative 4, possibly 2 of them at 1, and 1 at positive 4. So I'm going to do synthetic division. Check that out. 1, negative 2, negative 15, 32, negative 16, with negative 4, 1, negative 4, negative 6, 24, 9, negative 36, negative 4, 16, 0. So x plus 4. Okay, so now I'm going to layer in a 1, 1, 1, negative 5, negative 5, 4, 4, 0, cool. So x minus 1. I should layer in another 1, 1, 1, negative 4, negative 4, 0. So x minus 1. Layer in my positive 4, 1, 4, 0. Excellent. They all worked. X minus 4. Okay. One last one. Let's try, wow. Again, there will be 4 zeros. And 4 corresponding factors. Unfortunately, I don't think I'm factoring that one. But I should always ask the question, do I think I can? Okay, so let's turn that one off and turn this one on. Okay. Okay. 1, 2, 3, 4, 5, 6. Negative 6 and something between 2 and 3. Negative 6 and something between 2 and 3. So I know for sure negative 6. And okay, the rest of them I'm not so sure about. So I'm hoping something really good happens when I use my negative 6. 2, 7, negative 22, 28, negative 120, 2, negative 12, negative 5, 30, 8, negative 48, negative 20, and 20. Ooh, at least that one works. X plus 6. Okay. I'm going to see if I can factor what's left over, because I'm not really sure about between two places where that one was. So from 4th degree to 3rd degree, so 2x cubed minus 5x squared plus 8x minus 20. And I can factor that. I can factor that by grouping. X squared, 2x minus 5. And I've got positive 4, 2x minus 5. So I've got 2x minus 5 with x squared plus 4 equals 0. Well, that's a linear factor. So 2x minus 5 is actually out there. But if you want to see what we're doing here, 2x minus 5 equals 0. And x squared plus 4 equals 0. Right? I'm actually trying to find zeros now. So 2x equals 5, and x equals 5 halves. So the 0 is at 5 halves. X squared equals negative 4. X equals plus or minus 2i. So again, we have 2i and negative 2i. So x minus 2i, x plus 2i. Okay, so just to sum up some of the things that we use, whenever we can factor, we do. If we can't factor, we go to the graph and try to pick up some of the zeros and do synthetic division to begin breaking down. If they confirm, that's great, and we may have to factor at the end. We may have to set things equal to 0 and solve them to get zeros, which we turn into factors. The thing we didn't practice in this video, which you should keep on the back burner, is doing the quadratic formula, because it could be true, and probably will be true at least once on our test, that you'll be able to break it down to some point and then have to do the quadratic formula to find the last two zeros and then turn them into factors.